In this video, we look at a program or algorithm for depth-first search. As we have already seen that a depth-first search uses a stack. So if we write a recursive function, it automatically uses a stack. So for writing depth-first search, already I have taken a data structure for this graph. This graph is represented as a adjacency matrix. See, there are 7 vertices, so I have taken 8 indices, so 8 by 8, two-dimensional array. But this 0th row and 0th column, I am not using it. And then this is a visited array. All are zeros, means no vertex is visited. Then what is the procedure? This is depth first search. Suppose a vertex u is passed, means the starting vertex. Starting vertex can be anything, let us say 1. If the starting vertex is 1, then what I have to do? First of all, check whether that vertex is visited or not. If visited of that vertex is equal to 0, means it is not visited, then visit it. So before visiting, print that vertex. Print %d vertex u. Print this one. This is printed. Then mark it as visited. See, assume that this is 1. Mark it as visited. Visited of u is 1. So mark this as 1. This is visited. Then start exploring it recursively. So for that, I need a for loop. So for v assign 1, v is less than or equal to n is the number of vertices, v plus plus. Then this for loop will go through all these elements in this first row. And every element we should check whether it is 0 or 1. If it is 1, then it's an edge. So here I will write down, if it is an edge in a vertex in a 2D array, that is matrix, at location u comma v, if it is equal to 1 means there is an edge, like u to v. Let us say v is a 2. So there is an edge. So perform depth first search on 2. So perform depth first search on 2. That is v. That's all. End of if, end of this one. So this will call itself again on vertex 2. Now this will be 2. And 2 is not visited, not visited. Print 2 and mark it as visited. Mark it as visited. Then scan through all the adjacent vertices of vertex 2. So now this is u. This is u because u is 2 now. So it will scan through this one. First one v, it's already visited. So nothing will happen. Next 0, it's not 1. So it will not call upon this. Then upon 3 it will call. So it will call upon 3 again. So this how it will continue. To avoid the call, if it is already visited, I can add one more condition, that and visited of v is not equal to 0. Then only call. If it is already visited, it will not call the function. Anyway, if it calls also, this condition will stop it. Then how stack is used and all, I will show you. Then how recursion work, you know very well. You can trace this and check upon any small graph. This is a sufficient small graph. It's not too large or too small. So upon this graph, you can try this one and see how it is calling itself. That's all about a program on depth first search. We will see the demonstration for this one.